This is the homework from last night. It was on page 103, 104. First one we want to try is number 5. So remember, we're looking at the graph that's in the book, and I'm going to try and draw what the graph looks like in the book. They would like us to know, they told us that f at x is equal to 7. So this is a y value. So we're looking where 7 is on our graph. So 7 is going to fall into about this range here. So we're going to come over on our graph, and then we're going to go straight down. So if you look at 7 on our graph and we come straight down, it comes to 3. So the answer to number 5 is 3. We're going to do the same thing with number 6. And again, I'm going to try and draw what is in the book, but it's not going to be perfect. Okay, so we're going to look at where number 7 is. Notice it's counting as 2, 4, 6. So I'm going to come over, and then I'm going to come straight down. And we're looking for where that is again, because we want f at 7. So if we did that correctly, it looks like it's going to happen at 4. So 4 is the answer to number 6. We didn't really assign this in our class, but it was assigned in the other. So we'll take a look at it. Where's number 8 on page 104? We have a graph that looks like this. I'm not going to draw in all of the axes. But if I look on the book, you see that this point right here is at 0, -1. This point right here is at 1, -1. The point up here is at 2, 1. Point down here is at 3, -1. The point up here is at 4, 1. The point here is at 5, -1. And then I'd say this looks like an endpoint. I don't know if this keeps going. Maybe those arrows on there mean it keeps going. I think those arrows mean it keeps going. So I think this is going that way and that way. If we look at number 8A, it says we want to do f at 3. So f at 3 is right here. So that's the answer. If we want to find f at 0, we're looking for the 0. That's going to give me -1. If I look at f at 6, so this point right here is the point 6, 1, or -1. So if we look at this point right here, we get to -1. And then we wanted to look at D as well. So letter D, they want to know, where is this increasing? We're going to use the x values to talk about where it's increasing. I'm going to draw it black where it's increasing. So as I go to the right and it's going up, that means it's increasing. So there's 2 places it's increasing. So it's increasing from 1 to 2, and it's also increasing from 3 to 4. The difference between this and the points aren't connected. These are connected, so we can say fluid. So these are not points. These are not points at all. This is just saying if I start at 1 and I go to 2, I'm increasing. I'm using a round bracket because where the round brackets take place is we're changing direction. Then 3 to 4, it's also increasing. Number 9, I'm going to draw without the axes. And let's just figure out some of those values. It looks like I have 1, 2, 3, 4, 5. This looks like -5, -1. This up here is 0, 2. Down here is 3, -1. This point up here is 5, 4. There was a couple other values we could do. If where this is crossing, this appears to be 2, 0. This appears to be negative 3, 0. And this last one, right about here, this is where it's crossing the x-axis, is about 3.5, comma 0. So if we wanted to go f at negative 3, this is a, f at negative 3. So we're looking for negative 3. What's the y value? 0. If I look for f at 0, I'm looking for the y value to be 0, which is this. So I get 2. And then f at 5 is equal to 4. And then we're doing letter D. Where is this increasing? Remember, increasing means as I go to the right, it's going up. So it's going up there, and it's going up there. So we're going to use the x values to talk about that. So from negative 5 to 0, from negative 5 to 0, we're increasing. And also from 3 to 5, we're increasing. Then on page 104, we wanted to finish up the rest of the problems. So we have two equations they gave us. We have f at x is equal to 2x minus 3. We have g at x is equal to x squared plus 1. Problem number 10, they want f at 3. So that means I'm going to use this equation. So I'm going to go 2 times 3 minus 3. So 6 minus 3 because 2 times 3 is 6. Gives me an answer of 3. Problem number 11, I want f at negative 1. So I'm still going to use the same equation. I'm going to plug negative 1 in for x and do the math. 2 times negative 1 is negative 2 minus 3 is negative 5. I'm going to go down to, and then we go to number 12. Let me change colors. Now we're going to go g at 0. That means I'm going to use this equation. So I'm going to plug 0 in for x, so I get 0 squared plus 1. 0 squared 0 plus 1 is 1. Number 13, I have g at 3. Means I'm going to plug 3 in for x. Do the math. 3 squared is 3 times 3, which is 9. 9 plus 1 is 10. Then number 15, we're going to go back to the f. F at negative 3. I'm going to take negative 3 and plug it in for x on our f equation. So that's negative 6 minus 3. That's negative 9. Number 15, I have g at negative 2. So I'm going to take negative 2 and plug it in for x on the other equation. So negative 2 squared plus 1. Negative 2 times negative 2 is positive 4 plus 1 is 5. Number 16, we want f at 0. So I'm going to plug 0 into our f equation. So I get 2 times 0 minus 3. 2 times 0 is 0. 0 and subtract 3 is negative 3. And then number 17, we want f at 2. So I'm going to plug 2 into our x. So I get 2 times 2 minus 3. 2 times 2 is 4. Minus 3 is 1. And that's all the homework would have been. Now we're going to go back to finish up the work from the other day. Okay. Taking a look where it's increasing. I'm going to make the line green where it's increasing. So as I go to the right, it's going up. And there's an arrow there. So it's increasing. Way this way is negative infinity. Way this way is positive infinity. Way down is negative infinity. Way up is positive infinity. So increasing, you're talking about the x value. So as I'm traveling this way and going in, it's increasing from negative infinity, because the arrow is on the end, all the way up to 0. And it's a soft bracket. We don't have a hard bracket there because that's where it changed directions. Now I'm going to show where it's decreasing. It's decreasing over here. As I go to the right, it goes down. And remember, there's an arrow still there. So where it's decreasing, it's going from 0 to infinity. And you're talking about this infinity because you're talking about the x direction. I'm then going to look at f at 3. So f at 3 is right there. So what is that y value? It appears to be 1. If I look at f at 0, I'm going to come up here. What's the y value? 4. If I look at f at negative 2, what's the y value? 2. The domain of this particular one, because they have the arrows at both ends, and it's going from left to right, from negative to positive infinity, we're going to list it that way. Our range is a little bit tougher to think about. So our range is, we're starting down here. This is where we're starting with our range, and we're going to go up. So I'm coming from negative infinity here, and I'm going to go all the way up to the 4. Okay, notice I use the y value. I'm going to put a hard bracket there. This bracket's hard bracket because that is a point. Okay, so our domain is just, our range is going to end as a hard bracket. And then we want to know where this is positive. So let me highlight this. So positive means above the x-axis. So this whole pink region here is where it's above the x-axis. So I have to figure out where it's crossing the x-axis and put a soft bracket. So it's crossing right here at negative 4. So from negative 4, comma, to positive 4, and those are both soft brackets because exactly at negative 4 and positive 4, the answer is 0, and that's not positive. Then we have this new graph, this nice curve. So I know this point right here is the point negative 3, 0. I know this point right here is 0, 90. I know this point up here is about 2.5, comma 150. And I know this point right here is at 5, comma 0. So we're going to talk about where it's increasing. Increasing means as I go to the right, it goes up. So from right there to right there, that's where it's increasing. I'm going to use the x values to talk about it. So from negative 3 to 2.5, it's increasing. And they're both soft brackets because those are turning points. Whereas this decreasing means as I go to the right, it goes down. So it's decreasing there and it's decreasing there. Okay, so we're going to use the x values. Well, I don't have an x value here because that's an arrow, so that's going from negative infinity. I have an arrow over here, that's going to positive infinity. So I'm going to go from negative infinity to negative 3 for decreasing. It's going down. And I also go from 2.5 to infinity. Then we have to answer f at 2. So I find 2, go up right about there. That's about 150-ish. Our graph's off a little bit, but that's okay. At 0, what's going on at 0? It's 90. At negative 3, where is that taking place? That is 0. Our domain to this one, because I have arrows on both ends, it goes forever left and right, so negative to positive infinity. Our range, well, this arrow is going to keep going up to infinity. This arrow is going to keep going down to negative infinity. Okay, so our range is going to go from negative to positive infinity as well. The intervals where this graph is positive, this is a little trickier. Okay, remember positive means it's above the x-axis. Let's make that a little bit darker. So above the x-axis. So all above here. But we can't have exactly on the x-axis as positive because that's 0. So we're going to list where is this interval where is positive. So I'm going to go from negative infinity to negative 3. That's above. Okay, it's soft bracket. And then I'm going to go from negative 3. That just means, because those points repeat, means I don't include that point, all the way to 5. Soft brackets. And that's all we have. Okay. Your homework for this will be to finish all problems on page 103 and 104. I hope this works out for you. Have a great day.